If you're going to explore space or alien worlds, you're going to want to have your open source science tricorder-like device, the Arducorder Mini. As a scientist, I strongly believe that knowledge and discovery bring about positive change and help us make positive social choices like reducing our emissions or working towards cleaner industry in our communities. That's why I designed the Arducorder Mini, an Arduino-compatible general sensing tool that's modular and pocket-sized to help us discover more about the world around us and make little discoveries everywhere. The Arducorder has a dozen different sensing modalities, a capacitive touch wheel interface, a powerful PIC32 microcontroller, and a CC3000 Wi-Fi module for uploading data to your favorite cloud service like data.sparkfun. I've designed the interface to play off the idea of live tiles, where here nearly every tile contains live sensor data. This allows the user to quickly and intuitively scroll through the data from every sensor in only a few seconds and zoom in on interesting data by selecting a tile. Now this is really cool. There's a large amount of data here from very different sensors, and it's great to be able to get an overview of an environment in only a few seconds. So here we're going to select the inertial measurement tile, which gives us data from the accelerometers and the gyros. And here we can see that the graph display has historical motion data that's auto-scaling. So if I shake the device, the tiny movements from being in my hand are dwarfed by this significant motion, and the graph scales back when that data is no longer in the recent history. Let's have a look at another sensor on the left, the low-resolution thermal imager. Now while the temperature profile of my hand is fairly uniform, here we can see the sun warming a spot on a desk, a hot cup of tea steeping, and my cat trying to eat a very cold popsicle. Now you may be asking, why is the thermal sensor in portrait rather than landscape mode? And that's because I'd like to combine it with the inertial measurement unit that we just saw using a technique called sensor fusion to take thermal panoramas very inexpensively. Now if we scroll over a bit, we can see one of the coolest sensors on this device, the Hamamatsu microspectrometer. This new spectrometer is tiny at only about a centimeter across, and it covers the entire visible spectrum from 380 nanometers in the near UV to 780 nanometers towards the near IR. Here I'm holding a cycling RGB LED in front of the spectrometer, and we can see different peaks corresponding to the red, green, and blue LEDs that make up this source, where the blue wavelengths are towards the left and the red are towards the right. Now here we can see a spectrum from a compact fluorescent lamp, which is usually mercury with a phosphorescent coating and looks very different from an LED spectrum, like we have here with this LED lamp. Now spectroscopy is basically the identification of different chemicals based on the light that they give off. Here, by examining the spectrum from this LCD monitor, can you guess which type of backlight it has? I'll give you a hint. It's an older monitor, and here we can see a spectrum that looks very much like a mercury fluorescent lamp. Let's have a look at the high-energy particle detector, which detects radiation from both normal background and other nearby sources, and displays this as counts per minute on the tile and counts per second on the graph. From developing the open-source CT scanner, I happen to have this cadmium-109 radioisotope check source handy, which primarily emits low-energy 22 kiloelectron-volt X-rays, as well as some gamma rays. And here we can see that if I place it near the detector, the counts per minute goes up dramatically on the graph. Now there are many other sensors on the Arducorder, including electromagnetic sensors like the magnetic field sensor here, and atmospheric sensors like this temperature and humidity graph. Here with the red temperature line we can see it's fairly warm, and so dry that it can actually sense the humidity from your sighs of exasperation while debugging the code. You might be thinking, this sounds super cool to use, but I bet it's kinda complicated to build or code for. Well, I have good news for you. I designed this thing to be built, used, reused, and modified from the tile engine and sensor drivers to the modular sensor boards and hardware. The idea is to make a serious scientific tool that's inexpensive enough that it can also be used by anyone for science education or discovery. And to reach out to young scientists, I've tried to design the software so that meaningful modifications can be made over a weekend, with a Learning for Arduino book in hand. With only one or two exceptions, most of the parts are off the shelf at major distributors. And while this isn't a first project in surface mount soldering, I literally soldered most of the parts in a toaster oven, so it shouldn't be too bad for folks with some experience under their belts. I'm Peter Jansen, and I build open source scientific tools so that we can better understand our worlds.